Welcome to Discrete Distributions in Probability. In this lesson, we will learn about three popular types: Bernoulli distribution, binomial distribution, Poisson distribution. These are core building blocks in probability and statistics. Let us jump in together. Running the cell now. We will bring in libraries for math, data, and plots. Warnings are turned off so things look clean and focused. NumPy helps with arrays and random events. Pandas helps us handle data easily. Matplotlib and Seaborn are for nice visual charts. Running the cell now. Let us load the Titanic dataset to use later for an example. This dataset was collected from real passengers. We print out the shape, or rows and columns. And we preview the first few lines to see what is inside. Running the cell now. What is a discrete distribution? A discrete distribution is a way to model situations where outcomes can only take certain values. For example, flipping a coin only heads or tails, or counting how many emails you receive per hour. Let us start with the Bernoulli distribution. Running the cell now. A Bernoulli distribution models a single event that is either a success or a failure. Here, the chance of heads is 50%. Let us call this P. We use NumPy to simulate just one flip. The result shows if it was heads or tails, as 1 or 0. Running the cell now. Now let us flip a coin 20 times using the Bernoulli model. This gives us a list of results, either 0 for tails or 1 for heads. We print those results to see what happened. Let us make a chart so we can visualize the number of heads and tails. The histogram count shows how many times each side appeared. We label the sides to make it easy to read. The chart title explains 20 flips with 2 possible outcomes. The y-axis shows the count of each outcome. And we display the chart to finish. Running the cell now. Binomial distribution. The binomial distribution models the number of successes you get in a set number of independent trials. For example, how many heads will you get if you flip a coin 10 times? Running the cell now. Let us flip a coin 10 times and count the number of heads. We set n to 10 for the number of trials. Probability stays at 50% for heads. NumPy gives us the number of heads we got in all 10 flips. We print the number of successes to see the result. Running the cell now. Try changing the number of flips or the probability and see how your results change. Let us repeat that experiment 1,000 times to see what is most likely. We use a loop to run the same set of coin flips over and over. A new plot will help us see the results. The histogram shows the frequencies for all numbers of heads. The x-axis shows possible counts of heads from 0 to 10. The y-axis gives us how often each result happened. The chart makes the pattern easy to spot for many experiments. The plot displays our simulated data. Running the cell now. Now let us estimate how likely it is to get 8 or more heads in 10 coin flips. We repeat the experiment 10,000 times. By counting how many had at least 8 heads, we find the probability. The result shows us the chance as a decimal rounded to 3 places. Running the cell now. Can you spot binomial distributions outside of coins? Any situation with repeated yes or no events can be modeled with binomial distributions. What about the number of passengers who survived on the Titanic? Running the cell now. Let us connect binomial distributions to a real example. We count the number of Titanic passengers with survivor data. The average of the survived column gives us the probability. We simulate the number of survivors using that probability. The printed message tells us about how many would survive with the same odds. Running the cell now. Think of other places in your life where binomial ideas show up. Try them in code. Poisson distribution. The Poisson distribution models how many times an event happens in a fixed interval when the events are rare and independent. For example, how many emails do you get in a day? Running the cell now. Suppose you expect about 5 emails per day, on average. We use the Poisson function to simulate one day. NumPy returns the count of emails for that day. We print the result so we can relate the number to real life. Running the cell now. Let us look at email activity over an entire month. We simulate 30 days of email counts. Then we make a bar chart with each day as a bar. X-axis is the day number, from 1 to 30. Y-axis tells us how many emails were received. The chart shows daily ups and downs in the data. Here comes our visualization. Running the cell now. We can find out which number of emails happens most often in a day. We use the Poisson model to simulate 10,000 days. Unique counts show us which results appear and how often. We look for the value that appears most frequently. The answer tells us what to expect on a typical day. Running the cell now. Now let us make this personal. Please enter your best guess for your daily email average. We simulate your email counts for the next 2 weeks. You will see the results as a list. Each number stands for a different day. Notice how the results sometimes vary even with the same average. Running the cell now. Want to challenge yourself? Try a new average and see the difference. And if you are enjoying this, tap like and subscribe to catch more tutorials. Summary table, when to use which discrete distribution. Situation typical model. 1 event, 2 outcomes Bernoulli. Many tries, 2 outcomes binomial. Rare events per interval Poisson. Running the cell now. Now let us try a mini-project. Suppose you work at a front desk where phone calls are rare, about 2 per hour. We simulate 100 hours at work. The Poisson model generates the number of calls for each hour. We use a histogram to see which call counts are most common. Color helps highlight the data in the plot. The x-axis labels the possible number of calls. Y-axis tells us how many hours matched each number. The title connects our experiment to the scenario. Let us show the results. Running the cell now. Self-check, try it yourself. Simulate 10,000 days and plot how many days have exactly 3 phone calls. Try it with different average rates, lambda, and see patterns. Keep exploring, and take notes on what you notice. Running the cell now. Recap and next steps. Great job learning about Bernoulli, binomial, and Poisson distributions. Next, you can dive deeper into real dataset analysis, or continue practicing with new problems. Try adapting the code for your own experiments. Running the cell now. If you found this helpful, like and subscribe. Share your results and questions in the comments, and check out our next Python stats video soon. Running the cell now.